Hi, this is episode 3, in which I wanted to get the trackball interface and some code going on that. However, I had a look at the GitHub site for the TDEC device, and I found no examples, and I did a search on the internet as well, and I have found absolutely no examples on how to use this trackball. So we will have to find that out by ourselves, and you might find it interesting how you can do that. In any case, when I started to look into that, as you can see, that little example in the background here, that graphic that I actually got from the LILYGO TDEC website, is actually wrong, which had me going in a loop for a while there. Yeah, so as you can see here, it's got the trackball, and it says up is GPIO 2, left is GPIO 1, right is GPIO 15, and down is GPIO 3. And of course, if you push the button down, the trackball down, it goes to GPIO 0. Now that's correct. It doubles as the boot button as well, to put it in sort of in a mode where you can upload the software to it. But these are wrong. And I trusted that they were correct. So I actually put that into my code, and as I was doing some initial tests, I noticed that I moved it left, it seemed to be going down, or if it's right, it's going up, or something like that. It was all confused. But in any case, I worked it out, and I also did find that there was another header file there that had them correctly defined. So if we look at the GitHub site, there are examples there, and initially they're all fairly similar, and they include a utilities H file, but the definitions in there for the actual trackball is actually these ones here: T-box G02, G01, G04, G03, 23115. And so I decided, well, I will just use the information that's on that graphic. So I created my own file where I defined those pins, and of course they were wrong, so it had me going in a loop there for a while to work out what was going on, because it seemed that the values were responding for, when you're going up it was left or something, and if you're going down it might have been right, or whatever it was, but it was wrong. But I did then eventually find, once I found out it was wrong, I had a closer look, and I found that in this LVGL example there is a TDEC pins H file, and it did have them defined here correctly. So down 15, left 1, right 2, and click 0, and up 3. Okay, so I could use those. But then when you looked at the values, well, let's have a look at the circuit diagram or the schematic again. You'll find out, as I said, the trackball here, it's got some ground connections. The actual button that it's, when you click it down, it goes to GPIO 0, and it was noted that it has a pull-up resistor, so we don't have to do input with pull-up on that one. But these guys here don't have any pull-up resistors, and we can see there's some chips there, AN481B, and we had a look at that before in one of the other episodes. But the actual pins directly are connected to GPIO 15 for GS3, GS1, GS2, and GS4. So they're all directly connected to GPIO pins. So in order to do readings on those, we have to work out what the values are of those chips. And if we have a look at that, actually I'm reminded that the device actually outputs only really 2 voltages, a high voltage and a low voltage. And this is the low to high or high to low, sort of a magnetic flux. So therefore, when there is movement, we are looking for transients. We're looking for it to go high and to go low. And each time it does that, that is a movement. And if we look at over here, we'll see that the output voltage is going to be from minus 0.3 volts to VCC, which is 3.3 volts plus 3. In any case, these pins are connected. The output pins here are actually connected to the GPIO pin, so therefore we can do an analog read on them, and after the maximum that it'll come back with is going to be 4095, which I've determined is true, and the minimum is going to be 0, but some of them are actually coming back with a very slight voltage. So it sometimes comes back with 0, 1, 2, or 3 or something like that, so we can take care of that in the code. Alright, so looking at the code here, so I also now have these TDEC trackball up, down, left and right defined correctly. So it's up 3, down 15, left is 1, right is 2. And of course the click, which is the actual button click, is 0. Okay, so this is what we have come up with for running the trackball. Now the trackball is actually connected directly to the ESP32, so we need to actually use interrupts in order to read the values up, down, left and right, because this would have to be done in the background of your main program. If you put it in your main loop, you would have an erratic cursor because you would be missing readings if you can't scan it continuously all the time. This is what we have done. So we've actually created a trackball HPP file, which is actually in the include folder over here. And what we have in there is, of course, the TDEC definitions for the pins. I have created a definition for the T-ball accelerator. I found that reading the values from the trackball and then moving only 1 pixel at a time made it very slow. So I put it as a define, so you can actually edit it, make it greater or lesser in that file here. This really is like a library file. So there is where you would edit that. And we need to keep track of the data when it moves. So it either goes up, down, left or right. So we've got a class for that. We have a class for the position of the cursor on the screen for the trackball cursor, and it would need to know where the X and Y position is, and also what the maximum values are, so it can actually deal with it to wrap around and so on. And we have a reset that sets it to the center of the screen. And we then have a class called movement, which is actually what's going to be used in order to communicate any movements that are happening in the background. And therefore we have a boolean called updated, which means that movement was updated while we were doing something else, so we better deal with it. And there's a reset there. The position originally is defined here. This is the position object. It goes to the center, and we looked at that just a minute ago. Takes the width -1, height -1 as the maximum. We then have an important movement over here, which you can see is volatile because it is going to be used by these interrupt service routines here. And of course, you can't have the front end program, the main program over here, actually accesses it and it checks whether there was an update to be dealt with. So you can't have it reading it while it is actually being modified by an interrupt service routine in the background. So this tells the system this is a special kind of value that has like a semaphore in it, and it is going to be locked when it is being accessed, by the front-end program or something like that. Then we have interrupt service routines for all there's 4 different pins there associated with the trackball. So if the trackball pin goes up or down, which is what happens when there is movement, and the whole sensors respond to the north to south, south to north magnetic fluxes. So then it will simply increase the move up value by the accelerator value, and it sets the updated semaphore to true. It says, hey, something has happened, so you better deal with it soon. And same with down, left, and right. Then we have a trackball class, which is actually the main class that this library actually exposes. And note that these HPP files are kind of neat because you can put the code in one file. You don't have to have a separate H and a CPP file. You can if you want to, but you don't have to. So I'll put all the code in here since it's relatively simple. Trackball class, there's no constructor needed for it. You do have a destructor to release the ISRs. Just seemed like the right thing to do. And there's a little flag here that says, oh, available, which is true if the setup has been run, and it's false if the setup hasn't been run yet. We have the actual assign ISR method over here that simply attaches the interrupts. So the trackball up, for instance, is pin 3 of the GPIO pin 3, and we then tell it to, when there's any change in it, that to call this T-ball up ISR routine, which you saw over here. That's the one here, and it has to be very short. So all it does is increments a value. And for good measure, we have release ISR to actually release the interrupt service routine on those pins. Perhaps in some code you might want to turn the trackball off or something like that for some reason, so you could do that way. Turn it back on again with the assign ISR. And then we have a little method here to update the movement. And again, we're telling it that movement is volatile, so that it knows that it's got to lock it out for the interrupt service routines while it is dealing with it. If there's any movement up, down, left, or right, then deal with it. Change the position of the cursor, in other words, and that's also being passed in over here. And then we have a reset after you have dealt with the movement in your front-end program. Then you would call that in order to actually set it back to 0 and say updated is false. And you can see that happening here in the loop, the main loop. That's all that you have to do. If M was updated, then update the movement to a new position, display that at that position, and reset the movement, and we are done. And of course, you can put other code in this loop here as well. And if there is any delay in scanning for updated, it doesn't matter because it would have simply in the background, the interrupt service routines would have added 10, 20, 30, whatever it is to the count, and the cursor would still move in the right direction. Setup is simple. We are using the TFT display, so we got to set that up. There's some pins that the actual TDAC needs for it to operate properly. That's what we are doing over here. And then this trackball object is actually defined over here. We're calling it TB, and we can even select the cursor character over here. You can change it if you want to. I've got it set to the letter O right now. And this is just to display the actual trackball cursor, which is just a character for now. And when you use the trackball, after you define all the pins and do everything else, the last thing you want to do is to do trackball setup, and then reset the position, and which goes to the middle of the screen, and then display at that position to start with, and then we just got that loop that is continuously looking for if something is updated and it moves it. So that's just the test code for that. So relatively simple. So this therefore trackball HVP is working, and anytime you want to use the trackball, that's all you have to do is put it, define it, and call these methods and functions here. So next we can go and try it and see if it compiles and upload it to the device. Okay, just to remember, this thing over here, before you can upload code to it, you have to hold down the reset button, which is on the side there, and hold down the trackball button, release the reset button, release the trackball button, and now it is in a mode where we can actually say compile and upload. This we can do from here. Don't forget the code, links to the code, and any information to do with this device so far will be in the description. You will be able to get it from there, and if you have one of these and you want to try this out. Okay, so we have a success. Then the next thing we need to do is to hit the reset button again, and there is our letter O that we're using as a cursor, and as you can see, we can move it in all directions, and if it'll wrap around, top, bottom, whatever. And the video I'm recording is only 30 frames a second, but in my when I'm looking at it with my eyes, it is moving quite smoothly, more than what you probably can see on the screen. In any case, it's all working. So this has been a successful session so far. So don't forget to, this is all we're doing with the trackball. Next, we're going to be looking at the keyboard, and we go on from there. So don't forget to like and subscribe, and to hit the bell button so you'll be notified if there's any more episodes. And as I said, the description will have links to the previous episodes that you can watch, and how we put this thing together, we made a case for it, and all that kind of stuff. In any case, I'll see you guys later.